Okay, Algebra 1. Welcome to PE3, multiplying polynomials, or I can multiply polynomials. We're going to do the expressions versions of things. You'll see another version of this in Algebra 2. But we're going to go ahead and get this started. What's really kind of cool is you've seen all of the elements to this, but may not have ever seen them put together in the way that we're going to do it. So let's go and take a look here. We're going to skip the algebra tiles and go right into this thing right here. And we're going to look at this. It says multiplying binomials using the distributive property. I'm going to highlight some things here. Distributive property. Distributive property is something we already know. We've already done this. We've already worked with it. That's something we've worked with for a while, right? Distribution. We're distributing something through generally a set of parentheses or a grouping symbol. The other one, another word here, well, we know what multiplying is. Then this other word in here, binomials. Hopefully you understand the prefix or the beginning part of that, bi meaning two, nomials meaning terms. We've already done some stuff with terms at the beginning of the year. So hopefully this is kind of bringing some stuff full circle for you. In other words, we're going to be multiplying two terms using distribution. And how does that work? Well, you can kind of already see it, but I'm going to write it over here anyway. I've got x plus 5 times x plus 2, right? These are two binomials. Basically, what needs to happen is I need to multiply the first binomial by the second binomial, or the second by the first, however you want to do it. But what I'm going to do is I'm going to take this x value, this first term, and multiply it by the entire second term. I'm going to make it look like this. I'm going to write this out a little differently than they have. I'm going to say x times x plus 2. But I also have to multiply the 5 times everything in the second binomial. In other words, plus 5 times x plus 2. So essentially, I've distributed one time, and I need to distribute a second time. Well, actually, two more times, right? Because this is the part of distribution where we normally see it, right? X times x, which is x squared, x times 2 plus 2x, 5 times x plus 5x plus 5 times 2, which is 10. And hopefully at this point, now you're saying, hey, wait a second, I can simplify this a little further. Now I can't add x squareds to anything else that doesn't have an x squared, but I've got two terms that just have x's. Same variable, same exponent. We can combine these. X squared plus 7x plus 10. And you'll notice they match. So we've distributed, essentially we distribute a couple different times. We're going to distribute, then distribute again. All right. And that's multiplying polynomials using the distributive property. Or binomials. We'll talk about polynomials in a second here. But what if I do this one? I'm going to write this over here. 2x plus 4 times x plus 3. The same thing's going to happen. The 2x needs to be multiplied by everything over here. In other words, 2x times x plus 3. And then plus 4 times x plus 3. Now, if I do that, I'll do some distribution in here. 2x times x is 2x squared. 2x times 3 plus 6x. 4 times x plus 4x. 4 times 3 plus 12. Once again, we've got a term, one term with x squared, two terms with x's, and one constant. So I can combine the two x terms. I end up with 2x squared plus 10x plus 12. And that is how you simplify those. Now, surprisingly enough, guess what? It's your turn. It's your turn. Here you go. Number 3, give it a shot. Try the distribution method. See what happens. Come on back in a minute. Alrighty, time to come back and check your work. If you distribute through, you end up with x squared minus x minus 2. The reason being, when you distribute, you end up with x squared minus 2x plus 1x minus 2. Combine the terms, combine like terms, you're good to go. With that said, let's go ahead and move on. Now there is this way multiplying binomials. It only works for binomials though. using FOIL. And I'm okay if you've learned it. I'm going to stick with distribution. I think it's more applicable to many more terms than just binomials. I want to make sure we can do it for everything. FOIL, though, it does stand for first, outside, inside, last. Right in here, if you want to take a look at it, you're more than welcome to, but again, it only works for binomials. I'm going to focus on the polynomial aspect of this. So I'm going to go right to the next one, multiplying polynomials. So what happens is if we've got with more than two terms, more than binomials, let's say we've got three terms in something, we would call that a trinomial. You hear that tri, like three, right? Or four, and it just gets on and on and on. But FOIL doesn't work for those, but our distribution method does. So let's take a look at this. I've got x plus 2 times x squared minus 5x plus 4. In other words, we're going to do the same thing with distribution. We're going to say this is x times x squared plus or minus 5x plus 4 plus 2 times x squared minus 5x plus 4. Okay, so we started here and then went to here. We distributed through x times all of that, then 2 times all of that. We distribute through again. We get x cubed minus 5x squared plus 4x plus 2x squared minus 10x plus 8. Lots of distribution. Distribution, 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 distribution. Think of distribution. You're handing it out to everybody. You're distributing that constant through or the variable through. Now we need to look and can we combine terms, right? Simplify like terms like we did at the beginning of the year. We've got this x cubed. I've only had that one time. I'm going to write this x cubed. I have two terms that have squareds. I have negative 5x squared plus 2x squared. That leaves me with minus or negative 3x squared. So x cubed minus 3x squareds. I have two terms with just x's, positive 4 and negative 10x minus 6x, and only one term is a constant, plus 8. Do these match? I sure hope so. I sure hope so. Again, that's our distribution. Okay, that's distribution. Let's look at one more example here. Again, this is, I'm going to write ours to the side because that's just a lot of boxes. Well, we can look at it. 3x minus 4 times negative 2x squared plus 5x minus 6. Let's see, 3x times all of that stuff. So, and then minus 4 times all of that stuff. Oh, wow, they've got this all. No, never mind. We're going to do it on our own. 3x minus 4, 3x times negative 2x squared plus 5x minus 6. Oh, I might run out of room. That's all right. We'll do it like this. Minus 4 times negative 2x squared plus 5x minus 6. We can do this. Our first one, if we distribute through, we end up with negative 6x cubed to the third power there. That's what that means. Plus 15x squared minus 18x. That comes from our top one right here. On the next one, we get plus 8x squared minus 20x plus 24. If we combine our like terms, the first one we have a negative 6x cubed. I have two terms that have squareds right here, plus 23x squared. I have two terms with just plain x's. I get minus 38x and one constant, plus 24. So very interesting there. That is how we take care of multiplying polynomials. After that, it's just simplifying, combining like terms. Okay. Can the distributed property be used to multiply two trinomials? Absolutely. Distribute through just the same way. Number 9 doesn't say it, but this is your turn. I think that's the only your turn in here. And it goes to the next part, right? Yeah, there we go. Number 9, your turn. Give it a shot, see what you got, come back and check it. All righty, come on back and check that answer. If you do some distribution in there, you get some pretty interesting stuff. You end up with 3x to the 4th plus 13x cubed plus 4x squared minus 21x minus 7. So let's see how we're going to apply this in a little bit different way. Modeling with polynomial multiplication. Sometimes we got to do this for problem solving. We've got Trina. Trina's building a garden. She designs a rectangular garden with length. So in other words, the length is x plus 4, and the width is x plus 1. Okay. When x equals 4, what's the area of the garden? Now, you do need to do the distribution first before you plug that in. Otherwise, you could just say, well, put 4 in there and put 4 in there and solve. No, I want you to do this out first. It says use FOIL. I would like you to use distribution. And again, area is length times width, or x plus 4 times x plus 1. I end up with x times x plus 1 plus 4 times x plus 1. And if I distribute through, I get x squared plus x plus 4x plus 4. Simplify even further, I get x squared plus 5x plus 4. That is what y equals. And then we were told to plug 4 in for x. We get 16 plus 20 plus 4. That is 40, or 40 square feet. I know it's a little bit convoluted, but that's a good way to think about this one, okay? Let's look at our second part here. Oric has designed a rectangular mural that measures 20 feet in width and 30 feet in length. Laura has also designed a rectangular mural, but it measures x feet shorter on each side. In other words, Laura's is x feet less. So let's see here, 20 minus x here and 30 minus x here. What's the area? Well, we can multiply these two binomials together. And if we do that, we don't have to use FOIL. You can use distribution. It works just fine. You have 20 times 30 minus x times 30 minus x. With that, you get 600 minus 20x minus 30x plus x squared. Combine your like terms, you end up with 1x squared minus 50x plus 600. And now all we got to do, plug 6 in to figure it out. So 6 squared minus 50 times 6 plus 600, 6, not x. This is 36 minus 300 plus 600. We end up with 336. So the area of Laura's mural is 36 square feet. Hopefully you're seeing the trends here. Again, ask questions if you have them. Let's look at your turn. Okay, and I'm going to suggest that you maybe draw this one out, and I'm going to draw it out for you. Okay, it says the landscape architect is drawing a rectangular garden in the local park. The garden will be 20 feet long and 15 feet wide. The architect wants to place a walkway uniform width all the way around the garden. In other words, you got this extra. This is the walkway on the outside. Okay, what will the area that be? So this distance here, we're going to call x because we don't know it. It's a walkway all the way around. That's the hint I'm going to give. So give it a shot on your own and then come back and see what you got. Now, also, before you do that though, you're not going to get a value. You're just going to get a polynomial as a response here. Okay, hopefully that little hint helped you. What I'm going to point out here though, is we've got our length here is 20, and it's not just plus 1x, because you've got this distance of x and this distance of x, right? It's going around the entire outside. Just like the width is 15 plus 2x. So it's a trickier question. I like it for us to talk about, but not necessarily for a summative. but I like it to talk about, right? And if you multiply those two polynomials, you'll end up with 300 plus 70x plus 4x squared. Now, if you wanted to put it in standard form, you would put the biggest exponent first. You could also write this, actually, you should write this as 4x squared plus 70x plus 300. With that said, again, I kind of avoided the FOIL, but binomials can be multiplied by distribution as well. So that's what we're going to stick with. Hopefully, you guys are having a fantastic day wherever you are. I hope you guys are well. Take care. We'll talk to you soon.